Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we'll learn how to solve equations that have rational exponents. Now, real quickly, if you have x to the a over b power, that means one of two things. We can think of it as x to the a power and then taking the bth root of that, or we could apply the root first, the bth root of x, and then raise that to the a power. Let's hide that. And basically the way to solve this is by raising both sides to the reciprocal. Once you've isolated the term with the rational exponent, raise both sides to the reciprocal of that exponent. When we raise a power to a power, we multiply them. So in this example, we've got x to the 5/2. If we raise x to the 5/2 to the 2/5 power, 5/2 times 2/5 is 1, and that leaves us with just x. The tricky part, again, is going to be, what do we do with 1024 to the 2/5 power? So we end up with x equals 1024 to the 2/5 power, and we've got two options. Let's see if you can think of which one's going to be better. We can raise 1024 to the second power and then take the 5th root of that. 1024 squared is a number that's over 1,000,000, and then you've got to try to find the 5th root of that. Or we could try to take the 5th root of 1024 and then square that. Taking the 5th root first is going to make this number smaller quicker, and then squaring a smaller number will be less tedious. So the right thing to do here, I believe, is to take the 5th root of 1024, which happens to be 4. So one thing we could try is start raising numbers to the 5th power. 2 to the 5th power equals 32, too small. 3 to the 5th power equals 243, too small. On our calculator, try 4 to the 5th power and you'll hit 1024. So this is the same as 4 squared, or 16. The other way is going to be a lot more challenging. Now, one thing that we can try is on your calculator, you may be able to raise it to the 2/5 power. Let's take a look at how that goes on the scientific calculator. (1024), I press the exponent key, it's the one with the a to the b over it, and then I'm going to type 2 divided by 5, and there's my 16. Also, let's hit enter on that. I could just take the 5th root of 1024 first by pressing the nth root button on my calculator, and see where the cursor is? That's asking for the root I'm taking, and I'm taking the 5th root. Then in the radicand, I can type 1024. There's my 4. I mentioned trying trial and error. I said 2 to the 5th power, 32, too small. 3 to the 5th power, 243, too small. 4 to the 5th power, there was my 1024. So a few different ways to get there. They all lead to the same place at the end, though, and that is x equals 16. Now, that exponent with a 2 in the denominator means we're taking a square root, so that number would have to be positive here, and it was. The next problem is pretty similar, but once we figure out, once we do our exponent work, we still have to solve this equation for x when we're done. So here we've got everything raised to the 2/3 power, so to undo that, to clear that exponent, we're going to raise everything to the 3/2 power. 2x minus 5 to the 2/3 raised to the 3/2 power equals 9 to the 3/2 power. On the left side, that just leaves us with 2x minus 5. The other side is going to be 27, and here's how we get that. The denominator of 2 tells us we need a square root, so I'm going to take the square root of 9 and raise it to the 3rd power. The square root of 9 is one that we know. That's 3. So we've got 3 to the third power, and that's where the 27 comes from. Now I've got to solve this equation for x. I'm going to do that by adding 5 to both sides. 2x equals 32. Divide both sides by 2, and we get to x equals 16. Now if we substitute the 16 back in for x, we'll see the expression in parentheses is positive. It was a cube root anyway, so it didn't really matter. Our solution set here is 16. Quick note, I did 2 problems that both had x equals 16. The answer won't always be 16. All right, that's it for equations that have rational exponents. We'll come back and do a different type in the next video.